Lesson 8.6 is solving systems of linear equations by graphing. If you recall, earlier in the chapter we solved systems of linear equations, and that's when we solved for either both the x or both the y, then we set them equal to each other and solved the equation that way. And I told you back then that the actual solution is where two lines intersect. So not all systems of linear equations have graphs that intersect in one point. There's three possibilities for the graphs of a system of two linear equations, and each represents a different solution set. So here, if the lines intersect like this, then you have one solution. If they are parallel, the lines will have the same slope and different y-intercepts, and you can tell that they're not crossing at all. So in this case, there are no solutions. And here, this is the same line. They're not going to show it. I guess it's kind of cool that they showed it as purple, because red and blue, when you combine them, make the color purple. So this is the same line. It means that it has the same slope and the same y-intercept. And if that happens, there are infinitely many solutions, because every point on the line is a solution to both equations. So we're going to go ahead and graph this, and we're going to graph it using slope-intercept form. So this is going to be a little bit different too. I believe you did it a little last year in 7th grade, but you probably need a little refresher. So when we look at this, the first thing we want to do is make sure that they're in slope-intercept form. And this one sort of is. We don't have an x value. And remember, if we don't have an x, then it's a horizontal line. So I'm going to put a point on -1 for the y. And then let me go ahead and draw my line in here. I want an arrow at both ends. So my line is right here. So this is the line y equals -1. And now down here, this is in slope-intercept form, and I need the slope, which is the 2, and I need the y-intercept, which is -7. When you have the slope and the y-intercept, you put your initial point on the y-intercept, so it's -7. That's our starting point. Now my slope is 2. Remember, the slope is a ratio with a rise, and I need a run. So if there's no denominator, you just put a 1. So I'm going to rise up 2, and then I'm going to run 1 to the right, because that's going to make a positive slope. So I'll do it a couple times. Rise 2, run 1. Now I'm going to go ahead and draw the line, and I'm going to see where they intersect. And they intersect right here at this point. So my solution is the point 3, -1. Now it's asking us to check our answer. So we're going to substitute these, this point 3, -1 into both of these equations and see if it makes a true statement. So if I put it in here, my y is -1, and that equals -1. So it worked right here. When I substitute it into the second equation, y is -1 equals 2 times the x is 3 -7. And now I just have to work this out and make sure that it works, that it's a true statement. So -1 does equal -1. So it showed me that my graph was correct. I did graph those the right way. Okay, these two are going to take a little more work. I have x minus y equals 6, so I have to put it in slope-intercept form. Again, recall that's y equals mx plus b. We've solved this now a few times. So I'm going to subtract the x from both sides. I end up with a -y equals -x plus 6. Since this is -y, I have to divide by -1 everywhere. So y equals -x divided by -1 is positive x. I'm going to write a 1x. 6 divided by -1 is -6. So my slope here is 1. My y-intercept is -6. So I'll come up here to the -6. My slope is 1. So technically, it's 1 over 1, so I can get a rise and a run. What I've told students in the past is if you have a slope of 1, it's the diagonal, the positive diagonal of all these squares. So I'm just going on the diagonal, up 1 over 1, up 1 over 1, etc. So let's go ahead and draw the line here. I'll draw it big enough because I don't know where it's going to actually intersect. And then my next line, I have 2x equals 12 plus 2y. If you want to, you can write 2y plus 12 equals 2x, if that makes it feel a little more comfortable for you. So I know now that I need to subtract the 12 from both sides because I'm solving for the y. So 2y equals 2x minus 12 because I want to put the slope term first. Divide everything by 2 now. And y equals 1x minus 6. Looks a little familiar. My slope is 1, my y-intercept is negative 6. Negative 6. So I'll use a different color, and I come down to the negative 1, and I see that I'm using, it's the same thing. So I have the exact same line. It's the exact same line. I know mine are overlapping a little bit, but that's just a computer difficulty that I'm having right now. There we go. So if I want to know the solution, my answer is infinitely many. Many solutions. So that means I can pick any point that I want to test it. So I will just pick this point right here. It's 4, negative 2. So if I put that into this equation right here, I'll put it. I have 4 subtract negative 2 should equal 6. Well, I add the opposite, so 6 equals 6, so it worked in the top one. And for my next one, I have 2 times 4 equals 12 plus 2 times y is negative 2. So 8 equals 12 minus 4 because I have a 2 times a negative 2. And 8 equals 8, so it does check. And again, you could pick any of these points on the line and it would work. Let's try another one. This one, yay, is in slope-intercept form, so the slope is 4. The y-intercept is negative 3. So I'll come down to negative 3. My slope is technically 4 over 1. So up 4, 1, 2, 3, 4, and over 1. I like to do a few points just to get enough to line up for my graph, my line here. So I'll tweak it just a little bit. There we go. And then the next one I do have to put in slope-intercept form. So I have 2y minus 3x equals 4. I'll add 3x to both sides. So I end up with 2y equals 3x plus 4. Divide by 2. And y equals, this is just 3/2 x plus 2. So my slope is 3 over 2. And my y-intercept is 2. So I'll go up 2. And then my slope is 3 over 2, so I'll count 1, 2, 3 over 2, 1, 2, 3 over 2. And that's definitely enough. I can see where they're going to intersect. They intersect right here. And that is the point 2, 5. And then again, you can go ahead and check it to make sure that it's correct. Okay, next we have 2 skaters are racing towards the finish line of a race. The first skater has a 40-meter lead and is traveling at a rate of 12 meters per second. So we can write that equation. It's 12 meters per second, so that's the slope, plus they have a 40-meter head start, so there's their y-intercept. The second skater is traveling at a rate of 14 meters, so y equals 14x, and we're good. We don't add anything because they start at 0. How long will it take for the second skater to pass the first skater? So really we're going to see where they're the same, and then we'll see when the other one passes. So this first equation, my slope is 12, my y-intercept is 40. So I'll come down, it looks like we're going in steps of 25. So we'll say 40 is maybe right here, so just going to be sort of an estimate. And then my slope is 12, so 40 plus 12, I'm going to rise 12, so that's going to give me 62, and then I'm going to run 1, so it's kind of over like this. I'm not really fond of the way that they've put this slope and y-intercept. So what I'm going to do, I'm going to check a point. I'm going to say when x is 30, what is y? Because then I can just get another point to line it up with. So if x is 30, I have y equals 12 times 30 plus 40, and we'll see what that gives us. So 12 times 30 is 360 plus 40 is 400, which of course I don't have the line for 400. So let's try x equals 25 then. So if I do x equals 25, I have y equals 12 times 25 plus 40. So 12 times 25 plus 40 is 340. So at 25, I'm going to put a point up here around 340. And now I'll go ahead and draw this line. Oops. Okay, and now my other one is just y equals 14x, so I know I'm going to start at 0. And I can go up 14 and over 1, but I'm also going to see what it is at 25. So if I do y equals, so if I say x is 25, just so I can get another point, I have 14 times 25, and that's 350. So at 25, this is 350. So it's above it just a little bit. Let's see how I can graph this out. So it looks like they're equal right around here. So at 250 meters, it looks like they're going to pass them, and it's right here. And this is going in, looks like it's going in 2.5. So it looks like about maybe 17.5 seconds. If I add 2.5 onto there, they're going to be the same. So anything after that, the second one's going to go ahead and pass the first one. Alright, I do not have your assignment figured out yet, so again, I will let you know, because by the time you watch this video, I will have it